So we've talked about elements on the periodic table. Now let's talk about how elements can combine to form molecules or compounds. For example, our sodium chloride, which is our table salt, it's made up of sodium and it's made up of chlorine. Well, sodium alone is very poisonous and chlorine alone is also very poisonous. But when they combine together to form a compound, they are actually edible and essential nutrient for our bodies. So let's talk about how we represent chemical formulas for compounds by doing a couple of examples. If the compound containing 2 aluminum atoms to every 3 oxygen atoms, how do we represent such compound? We always want to write the metal before the non-metal, because if you think about it, on our periodic table, metals are to the left and non-metals are to the right. So we're going from left to right, just like we write English. So aluminum is written with the chemical symbol Al, and we have oxygen, which has the symbol O. Now we have 2 aluminums, so we represent that as a subscript right after the chemical symbol for aluminum, and we have 3 oxygens, so we write a 3 as a subscript right after the oxygen symbol. So in short, this is reading 2 aluminum atoms for every 3 oxygen atoms. Now let us do an example, example B. The compound containing 3 oxygen atoms to every sulfur atom. Well, you say, okay, those are both non-metals, so how do I go about doing this problem? We've learned that we go metal, non-metal, left to right. Now let's look at oxygen and sulfur, where they're located on our periodic table. We see that they're both in group 6A. So the general rule for atoms in the same, or elements in the same group, is bottom to top. So we write the bottom one first and the top one second. So in this case, sulfur is on the bottom, so that's going to go first, and oxygen is on the top. Now we have 1 sulfur atom for every 3 oxygen atoms. So here's our 3, so we write the 3 right after the oxygen. We don't have to write a 1 here because it's just assumed when we write it like this. If there's no subscript after a symbol, that means there's 1 of those. So you can write it just like that. So remember, the general rule is you write from left to right on the periodic table and from bottom to top. Now go ahead and give this a try and replay this video to see if you got the correct answer. Let's write the chemical formula for each compound. If we have a compound containing 2 silver atoms to every sulfur atom, okay, we can tell that silver, which has the chemical symbol Ag, is a metal, so it's going to go first. And we have 2 silver atoms for every sulfur atom. Sulfur is the nonmetal, so it goes second. So this is how we represent our compound. The compound containing 2 nitrogen atoms to every oxygen atoms. Again, we want to look, and those are 2 nonmetals, but we're going from left to right. So we're going to write N first, and we have 2 nitrogen atoms to every 1 oxygen atom. We have something called polyatomic ions, or groups of atoms that act as a unit, that we'll often see in chemical formulas, and we need to learn how to represent those and understand what they mean. In your book, there's a table 5.3 that has some of the common polyatomic ions that you simply have to memorize. You got to know every single one of them by heart, because you have to learn to recognize when you have those particular elements combined in that ratio, it's representative of that certain polyatomic ion. So when I see PO4 here in the first example, I learned to recognize it as PO4 with a -3 charge, which is the phosphate ion, and it comes as 1 unit. So here I have since I have parentheses around the phosphate and a 2 on the outside, it's saying I have, for every 2 phosphates, I have 3 magnesiums. Okay, but I'm asked here to determine the number of each type of atom. So how many magnesium, how many phosphate, how many oxygen. The magnesium, there's 3 magnesiums because of the subscript right next to it. You're tempted to probably say, okay, well, there's 1 phosphorus, but don't forget there's a 2 outside the parentheses that I have to carry in. So that's actually 2 phosphate. And then I also have to carry in this to the number of oxygens, but it's 4 times 2, which is 8 oxygens. For potassium sulfate, I learned to recognize the SO4 as sulfate with a -2 charge from my table 5.3. There is no parentheses around that, so that's saying for every 1 sulfate, there's 2 potassiums. So there's 2 potassiums. However, I want to know the type of atom. So how many sulfur do I have in this particular compound? I have 1 sulfur. And how many oxygens? I have 4 oxygens because I do not have the parentheses. I don't have to write this as SO4 with a 1 on the outside because that's assumed. Okay, now go ahead and try this on your own and determine the number of each type of atom in aluminum sulfate. Again, I learned to recognize that SO4 is the sulfate ion, and I have parentheses this time around it with a 3 on the outside of my sulfate. So this is saying that I have 3 sulfates for every 2 aluminum atoms, but I want to determine the type of each atom in aluminum sulfate. So I know that I have 2 aluminums here, and I have to carry the 3 on the outside of the parentheses on the inside. So I have 3 sulfurs and carry this also in here as well. So 3 times 4 is 12. That's 12 oxygens.